FAR, a structure activity relationship of adrenergic agents, because they are very important topic. And first of all, you know here, in case of SAR, they have one is a aromatic ring. Have you know?
Yes.
Have 2 carbon. After that, or amine. Then can you say phenyl, ethyl, you can say no?
Yes.
Phenylethylamine. Now see, we study first of all, first point, how many carbon in between phenyl and amine? 2.
Aromatic or phenyl, not aromatic.
Phenyl is aromatic. It means this is the essential for activity. If they have 2 carbon, essential for activity. If you do like this one, phenyl, or if you can do
More than.
CH2, 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 NH2, less activity, or very less activity as second range. Now in questions in your exam, which of the following compound is the pharmacophore of
Again, sir.
adrenergic agent? First one, second one, and third one.
Third one.
Third one.
I thought that was so.
Because
So ethyl group important in activity.
it means the presence of ethyl group in between phenyl and amine is essential. Only 2, not 1, not 3. Yani not less than 2, not more than 2. It will increase. Please, every point should clear. Otherwise, now see here.
Doctor,
Yeah.
R3 is connected to the benzene directly or what?
Are connected to benzene.
How it is connected in the middle? No, I mean R3 here.
Yes.
Ah,
How it
this
is connected to the
R3,
middle?
they dancing to all.
Ah.
That's why I did in middle. If I do here, they should present on only 3. If I do here, the 100% 4. But I write in the middle, it means they are dancing, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6.
Yeah, I got it.
Again, please.
I write this line in the middle.
Okay.
It means they are revolving either 2, either 3, either 4, either 5, either 6.
For this R.
These are.
This R from
I will come, then I will discuss. Don't worry. First I will discuss nature of this one.
R1.
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 Now,
So difficult point. How are you see here in H2? We can in H2, not R. For example, okay, this aromatic and in H2, not in HR.
if R1 is equal to hydrogen,
Yes.
then what happens?
Not selected for adrenergic.
This is another thing. If R1 is equal to hydrogen, what happens? NH2, no?
Yes.
This is the NH2. This is the simple thing. You are asking, I think, 2 or 3 lines ahead. I am going to teach, then you can do. Okay? First of all, see here. First thing is that here. See this structure. Same structure. This is structure and this is structure. Now here I have alpha carbon. This one beta
Beta.
carbon. First of all, my request is don't confuse this alpha carbon to alpha receptor. Don't confuse this beta carbon to beta receptor. It does not mean they act on the beta receptor. It does not mean they act on the alpha receptor. This is the alpha carbon, this is the beta carbon.
To the N terminal.
To the N terminal, from N terminal. Now see here, first line is, if here R2 is equal to H, then how many chiral carbon they have? Chiral carbon, the whole compound, how many they have chiral carbon?
Two.
One.
Two.
Honey?
One.
Yes, one.
Why? Because only beta.
Only beta, wow.
How?
Because here have hydrogen. Here have hydrogen. Very good. But if here have CH3, then
Two.
very good. Very good. If there are two chiral carbon, how many structure?
Two structure.
Four.
Four. Please give all answer. The back sides, please understand or no? Eh? If they have two chiral carbon, they have how many structure? If they have one chiral carbon, how many structure? 110% I will give the questions in your exam.
How many structure?
Yeah.
You just multiply by two.
Huh? Now come on here. Chiral carbon is equal to 2 to the power n. N is the number of chiral carbon. If the 1, 2 structure. If the 2, 4 structure. If 3, 8 structure. Now see here. Separation of aromatic ring and amino group. Separation of aromatic ring and amino group. How many carbon? 2. I just discussed. If they have 2 carbon, they have the maximum activity. If they have 1 carbon and 3 carbon, they have the less activity. Just I discussed. Now see. Yes. Second thing is that presence of OH group on beta carbon is essential for activity because they make which bond? Which bond? Hydrogen bond. OH group. Now see R1 substitution. R1. Now I am going to directly on R1. R1 substitution in the aromatic ring or amino side chains determines the compounds will attack where? Alpha or beta? Receptor. This is the receptor and this is the carbon. Again I am going to deal with you. Please don't confuse this one to that one. This R1, what he did, they determine compound will act on alpha receptor or
beta.
determine.
Oh.
So doctor, it's for the drug. Where it's going.
For the drug. For the whole drug, this R1 determine where they act, alpha or beta.
How?
How? Very good questions. How? Like suppose that here. Don't have one more duster? You only one duster, no? The last time we had 2 duster. Where's one? Oh, is there? I have 1 minute, 1 minute. I am coming. I am coming with you, please. If R1 is equal to hydrogen, if R1 is equal to CH3, R1. If R1 is equal to C2H5, if R1 is equal to C3S7, C3S7. If R1 is equal to any big group, if R1 is equal to any aromatic or heteroaromatic. Now see here, my dear, please tell me. The lipophilicity of the compound increases. Here is very less lipophilic or no lipophilic.
Yes.
Lipophilic, more lipophilic,
More. How?
and more. मतलब too much. यानी lipophilicity increases.
Yes.
First point. Second point, as compared to alpha receptor and beta receptor, alpha receptor is very less lipophilic.
Very less lipophilic.
But in case of beta is very, very high lipophilic. Yani, if R is equal to hydrogen, they go on. If R is equal to CH3,
Alpha.
50% alpha, 50% beta.
Yes.
But if R is equal to C2H5, they 100% go to beta.
Depending on the energy of the lipophilic. If it's is high or low.
I am going to again repeat. See here, please. That's why I am telling here R1 it determines the whole compound. R1 determines the whole compound act on alpha receptor or beta receptor. I want to give here example. H, CH3, C2H5, C3H7, very high and very high. You know about them. Lipophilicity increases.
Yes.
Now, if R1 is equal to hydrogen, they act on
Alpha.
100% on alpha.
Because less hydrophobic.
Less hydrophobic.
No hydrophobic.
No hydrophobic.
Okay.
Because alpha receptor is very, very less
Lipophilic.
hydrophobic. Same thing.
Or lipophilic.
Same thing. Now, CH3, if they have CH3, they are 50% on alpha and 50% on
Beta.
because again they are less lipophilic as compared to this one. But have this one beta, beta, beta and beta. Because beta receptor is,
Lipophilic.
now you understand?
Aromatic picture is 100% for beta.
100%.
What about the size?
But
What about the size?
I am going to eat.
C2H5.
See here. Now come on here. R1 substitution on the amino nitrogen determines compound act on alpha
Or beta.
receptor. The amino group is essential for activity, you know,
Yes.
because they make bond. I will discuss what they make bond. If replacing nitrogen with carbon, if this nitrogen will replace with carbon, so then here bond will destroy, so that we cannot replace this nitrogen with carbon. It means nitrogen is essential for activity. If replace the carbon, then activity of the
I
compound.
mean, Dr. Alpha bond will be broken, right?
Yes. Now, the activity is also affected by the number of substitutions on the nitrogen. I discuss here. Like suppose that here have hydrogen. Then go to alpha receptor.
Yes.
You know about that?
Yes.
If here have CH3, alpha and beta. But here have C2H5,
Beta.
100% beta. More than CH3, go to beta. Because they increases the lipophility. Because you know, beta receptor is more lipophilic in nature as compared to
Beta.
alpha receptor.
Beta more, yeah.
Beta is more as compared to alpha receptor. Now,
يعني الحين الفا وبيتا هي تقصد الالفا ريسبتور مو بالكربون. مو الكربون. I think you mean alpha 1 and beta, it's a carbon, not a receptor.
that's why previously I advised you, I request you, I told, I am requesting you, please don't compare alpha carbon to alpha receptor. Don't compare beta receptor, beta carbon to beta receptor. When I enter here, I request you. I think you are not here. What I told. See here, come on. See, it means if here have CH3, this hydrogen will be CH3, then they are tertiary amine. You know tertiary amine? Our this one, secondary. This one,
Quaternary.
this one. Now see here. Primary and secondary amine have good activity, but tertiary and quaternary amine have no activity. You know why? Because again they have causing steric hindrance
Yes.
on this nitrogen. It means if they have either hydrogen and hydrogen, primary amine, or secondary amine,
It's okay.
they have the good activity, but even tertiary and quaternary
No.
no activity because they have steric hindrance. Now see next point. See here, Next point. The nature of amino substituents also dramatically affects the receptor selectivity, just I discussed. As the size of the nitrogen substitution increases, then what happens? Alpha receptor agonist activity decreases. If you increase,
Decrease.
then decreases the alpha receptor activity, but at the same time, beta receptor agonist activity increases. Now, when R1 is equal to hydrogen, source alpha receptor. If R1 is equal to alkyl groups like CH3, the activity is more at beta as compared to
Alpha.
yani 50-50%. Now, if when R1 is equal to bulky alkyl groups like this one, then compounds change to only
Beta.
now, for the conclusion, therefore, as bulky olefinic groups substituents at R1, then the compounds have more affinity towards beta receptor because beta receptor contains more
Lipophilic
binding
site.
site. This is all about.
If I put hydrogen, it's two receptor will be work or only alpha?
Alpha,
Only alpha.
100% alpha.
Beta not work.
Never. But if-
CH3 both.
Both. But if you add C2H5, alpha receptor off, beta receptor on.
C
C2H5.
C2H5 or from C2H5 to heterocyclic, it's a beta.
Only beta.
Okay.
No alpha. Now my question in exam. They have R1, they have R2, they have R3. Which of the following are responsible for determines the compound's receptor selectivity?
R1.
Understand?
Yes.
Understand? This is the question in the exam. Then I add here R1 is equal to hydrogen, then what will happen? R1 is equal to CH3, what will happen? If R1 is equal to more than CH3, then what will happen? You know about that. Because if you increase the R1, then lipophilicity increases so that the compound tends to on beta receptor. Tends to beta receptor because beta receptor is more lipophilic in nature as compared to. Now come on here. R2. Before R2, I want to discuss one thing. You give me answer because already I talked.
Dr. Muhammad, can I ask you a question? Victor, in the exam, if you give us aromatic and heterocyclic and propyl group and methyl, all of these are beta receptor except we choose methyl group or not.
No. In case of methyl, I give the option in 50-50%. I'll give option in first option. They are 50% alpha, 50% beta. Then you choose A option. 50% alpha, 50% beta.
Oh,
Methyl.
except this the exception. All of the others are for beta. Only this 50-50. Okay. So that it's correct answer 50 and
50.
Okay.
Second question is you give me answer. Anyone give me answer. Don't worry. This is structure. Is epinephrine or not epinephrine, or you can see the catecholamines. Here are two enzymes. One is MAO. One is CMT. CMT. Can I write this one? CH. CH. Any problem?
Yes. No.
No problem. Can I write here R?
Okay.
R is equal to hydrogen? No, maybe you get confused. R. H.
دخلت منه.
See, now Now my question is, Mao failed the attack.
Amount chain.
Amino chain. Then amino chain change to
The hard.
I am right?
Yeah, right.
Right. Now, this hydrogen is very less atomic number. 1. Very less. Is this hydrogen, if replaced with CH3, or if replaced with C2H5, then, please, if you replace this hydrogen by CH3 and C2H5, then both of this group protect this amino group from mountain. Yani, if this one R2 is replaced by CH3 or C2H5, then the activity of the compound very good.
And decrease metabolism by mouth.
Yes.
Decrease.
Decrease metabolism or increase activity.
Yeah.
Okay.
Same thing.
So maybe it's more enter the CNS or not? Because they were collecting.
I'm coming on that point. Again, you're asking the ahead. Don't worry. I'm
So,
coming on that point.
again?
I will discuss your questions.
Again,
Here, this hydrogen, if replaced with CH3 or C2H5, or I am coming on the R2. If R2 is replaced with CH3 and C2H5, then they will act as a steric shield to the amino group from Mao enzyme, so that Mao enzyme not attack here. If they are not attacked, no metabolism. If there are no metabolism, maximum drug reach to the target site. More concentration for the more activity. If you replace R2 from this group, then this group, the activity of the compound increases. See here, I written R2 can be substituted by a small group such as CH3 and C2H5. Then what happens? The activity is slightly very danger. Very danger. Please, right here, increases.
Decrease.
Oh.
Big mistake.
Very big mistake. Mehdi, this is your duty, please.
Okay.
Right here,
Decrease,
increase.
It's slide number 11.
Please, all are hearing here what I am saying. The activity slightly increases. This is my fault, sorry.
Okay.
Increases as compared to 915 because the duration of action,
increase.
because that groups resist or prevent their metabolism by clear. Please do here increase.
How can we protect category?
I am not talking coloring.
Okay, from CO1C.
I am not talking.
PG.
When I will come, now I delete. I am not talking. When I will come category, I will talk COT. Getting? I will talk only side chain. See. Then what happens? It means my second question is exam. Which of the following are? They have R1, R2, and R3. Which of the following are is responsible for protecting from Mao enzyme? R1 and R2. Most of the students I know, they will do wrong because he will think, nitrogen, they have R1. But do R2.
R1 for selective for alpha 1 or alpha 2 or beta, alpha or beta. R2 for protect from Mao.
Most of the students do wrong, I know. But please, I am requesting you know today. Because student in the last year did mostly wrong. I given the same questions. He think your senior classes, Tehsil, he think, here. Maybe Mao will attack here. It means they will protect. No, they will responsible for receptor selectivity, alpha or beta. But this will fall only from Mao. Now come on here. OH group, nothing. OH group is not role. What is the role? Only hydrogen.
So if I replace R2 with OH,
R2
with OH.
we cannot do. Activity decreases.
Decreases.
Negligible or diminish the activity.
Only CH3 or C2?
Only CH3, C2H5, not C3H7.
Oh.
Huh? Only methyl ethyl.
Only.
If I aromatic, it's not a protect.
No. Now, yes. What is your name? Your name? Your. No, this one. Now I am coming CMT. Now I am coming catechol. R3 substitution. R3 substitution. Because complete R1, complete R2. Now I will come on R3. Come on here. See, give me your answer. Here. They have CMT, catecholing system.
Yeah.
They will metabolize by
Count.
Then I want to prevent metabolism from CMT. Then what I do? This compound metabolized by CMT.
Protect OH group because
Change
it's
the position of OH.
Change position.
yeah OH.
Yes, change the position.
Protect OH.
Also protect. They also right. But better to change the position. My second question, can this compound metabolize by CMT?
So converted to
Honey,
ester.
I think, honey, this is your problem, honey, you know, because you are going to deep, what I am saying, you are not concentrating. Now my second question, can this compound metabolize CMT? No. Can this compound metabolize CMT?
No.
It means changing the position. Change the position.
We have two OH
Here. Catechol. That's why the first day I discussed what is benzene, what is phenol, what is catechol, what is isocinol. I discussed now.
Yes.
I discussed the first day.
Yeah.
Because CMT needs catechol.
Yeah.
But this one is not catechol. This is not catechol.
But seven
I am coming. See here, R3 substitution. Where is R3? On the ring.
ما حط
That's why to protect the catechol from metabolize.
I am coming. See. See, where is R3? Aromatic ring, no? See, presence of OH group on 3' position. See, where is 3'?
Yes.
See 3'
Yeah. Okay.
is responsible for alpha activity. But presence of OH group at 4th position, they are responsible for beta activity.
Beta.
Now, what happens? Presence of OH group at both position, yani here and here,
Alpha and beta.
alpha and beta, activity increases, but the same time
Alpha.
metabolized by
Count.
CMT, yani duration of action of a compound decreased, huh?
Decrease, yeah.
And then what is called as see here,
And increase the
presence of OH group both at 3rd and 4th position, then activity compound increases, but metabolized by CMT
Decrease.
poor, shorter,
Duration of action.
hydrophilic, poor,
CNS activity.
all are linked in dash. See, I given in flow chart form. Getting or no? Then I want to change. Here
Yes.
and here. Then what happens?
Decrease.
Eh? Not attack. Then
Decrease
Then-
duration.
activity.
decrease.
Yeah. Yes. See here. See. See here. Here. But first clear this line, please. absence of OH group, at third and fourth position,
Decrease.
activity decreases because here no hydrogen bond, but the same time they increase lipophilicity,
Yes.
so that the compounds intend to the
CNS.
Activity decrease and increase lipophilic.
lively. Honey, you understand. Writing is a different thing. First understand, because your mind is going to write it, so that I think you don't get understand. First you understand what I am saying, what you discussing and going. You are writing too much. Maybe you forget. So first understand. Come on here. Here I have OH group. Here I have OH group. Too much polar. Again they metabolize COMT. See here. Presence of OH group both at third and fourth positions increases both alpha and beta, but at the same time metabolized by COMT increases poor oral activity, shorter hydro, poor CNS activity. Now I want to delete both. Absence of OH group at third and fourth position, activity decreases because you know they act on the hydrogen bond, but at the same time lipophilicity increases. Then the compound intend to the CNS. This is the discussion. Now come on here. What happens if the OH group and third position and fifth position? Abdullah already given the answer. See here. Presence of OH group at third position and fifth position increases beta receptor, alpha receptor, metabolized by COMT decrease because they are not COMT, not catechol, they are resorcinol. Getting my point? Yani increase
Duration of action.
Getting my point?
Yes.
That's why yesterday or one day before I discussed what is benzene, what is phenol, what is catechol, what is resorcinol, what is 1,4-dihydroxybenzene. I discussed. Now come on here. My second question is that. What happens here? Here I have OH group, and here I have also OH group. Can this compound metabolize COMT?
No.
Why? Why, honey? Wow. Understand, mashallah. Because this one OH group not directly attached to the aromatic ring. This is the primary one. Very good. It means again, even they have two OH group. In the last year, a student did a lot of wrong. Again, I given the same questions. A student write yes, because of two OH group catechol. They are no catechol. They are not catechol. Because this OH group not directly linked to the aromatic.
Yes.
They link to benzylic carbon. Very good. Very good. I written here. See here. Presence of CH2H at third position, and OH group at fourth position. Then increases metabolizes COMT because they are not catechol.
Yes.
Increase,
Absorption.
increase. All are interlinked. Abdul Rahman, understand?
Yes.
Now, what happens if catecholamines have no OH group? More lipophilic?
More serious.
More lipophilic?
More duration of action, more activity.
Yes. See here. All this one. See, that's why they have, see, cross, have CNS, all this one. Have catechol? No. Can? Now my second question. 1 minute, don't give me. You last. Yes. Which of the following compound? Don't give me anyone, please. 1, 2, 3, and 4. Which of the following compound metabolized by CMT? CMT in catechol or methyl transferase. Second one. Is anyone?
No.
None of them. None of them. Because no any compound have catechol. Second questions. Yes.
Which one is more active? The one with the primary alcohol or the one with 3 and 5?
3 and 5.
More active? More duration of action?
Let us understand.
Why?
Because, see here, and 1 minute, I will explain just see here. And I'll explain your questions again. See here, next question is here to all of them. Which of the following compound is metabolized by enzyme?
First one.
Very good. Oh, very good. Amine group is not protected, but here are protections, here are protections, here are protections. A second thing, which of the following compound make dipole interaction?
Fourth one.
The last one.
Fourth one.
The same question I given in
The last
quizzes.
one.
MashaAllah, the same question.
Fourth one.
Put it in the
Fourth one.
But it's number 5.
Question number 5.
what's the question again, Doctor?
Question 5 انتظروا
Ketone.
Yeah.
Ketone.
And second question here.
الاختبار
Nothing.
انا فاكره في دقيقة
Thunder structure.
Now see here 1 minute. See here 1 minute. We all know about them. This makes which bond? Please tell me all. Which I make?
Hydrogen.
This one?
Hydrophobic or van der Waals?
This one?
Hydrophobic. Hydrophobic.
This one?
Ionic.
This one? All are written here. All are?
But I have this. R NHR2.
NHR2.
Yes. If I replace one R with H, it's hydrogen bond because secondary amine.
Secondary? Yes.
Amine.
Yeah. Same thing. You ask the question the same thing in WhatsApp. I know your question is the genuine. Also you give the answer. That's why I did not reply. If I replied, you get confused. The same question you ask on my WhatsApp number. I know.
I ask you.
Now see here. Which bond? What is this one?
Serine.
Which bond? What is this one? Now, which bond? What is this one?
Asparagine.
Asparagine. Yani which one conclusion? Serine
And
and
asparagine.
asparagine make hydrogen bond.
Histidine.
Now here,
Phenylalanine.
in case of here, we need 4. Phenylalanine, tyrosine, and tryptophan.
They make hydrophobic.
Hydrophobic. Or van der Waals.
Tyrosine also.
Tyrosine also.
Tyrosine and
Phenylalanine,
and
tyrosine, tryptophan. Make van der Waals as well as hydrophobic interaction. Now see here, this positive part. Here,
ionic.
What is this one?
Aspartic acid.
Asparagine.
Because
not asparagine,
aspartate.
aspartic acid. They are aspartate.
Aspartate makes ionic bond. Victor, hydrogen bond. Histidine. Histidine, it's HI.
HIS.
Yes.
In the next semester, please. Here no only 2. In next semester, I will explain too much.
Because the lecture will be in receptor as a drug target will be right. Histidine in the like this, okay? And histidine hydrogen bond.
Yes. What is the next? I think this question you receptor direct target in the last second slide. In
Yes,
case of in case of cholesterol.
Yes.
Now I want to ask 2 questions. Last to you. This one compound. This one two compound. I am not doing up. First compound, see second compound very carefully. And give me answer. This fifth compound act on alpha receptor, fifth compound act on beta receptor. Don't give anyone an answer, please.
Okay.
Last.
On the left one, it acts on the alpha because hydrogen.
Yeah.
And this beta. Now this one also alpha because nitrogen has hydrogen.
Have C, CH3, CH3, CH3.
No activity.
Where?
No activity.
Alpha and beta.
No.
Beta, but it is activity.
No,
Because no protection.
Only beta.
Only beta.
Because greater than.
Why doctor?
Methyl,
Because more than methyl.
Yes.
If there is more than methyl, we say it beta.
Yes. Here. There isobutyl. You know butyl group? Isobutyl group, this one.
Yes.
Also I written in the down. That's why I protect. See. Alpha and beta. That's why I protect. Now my question is here. From first compound and second compound, which of the following compound act on beta receptor? Now,
Alpha receptor.
now here, this one, first group, this one, second group, this one, third group. Which of the following group responsible for act on the beta receptor?
Third one.
Third.
Now you get point?
Yes.
This is the comparison. This is the comparison. Because here N, here I have R1.
Yes.
R1 determines the compound act on alpha and beta. Now second thing, you give me again answer. Now because I did SAR, then you give me answer. To you.
Okay.
This compound and this compound, first and second.
Yes.
Which of the following compound multiplied by CMT?
Second.
Second.
No.
No.
Alcaticol.
No. No.
One on.
None of them.
What was the question?
Have no CMT, no catechol. Now, in case of Mao, I want to give you one. I want to give you one information because according to SAR, you know only this protected. Only this. But I want to give you one information more. Please keep in your mind. Even here have CH3. Even here have C2H5. Even here have more than, they are also protected. It means in the new book, they are added, here have CH3, or here have CH3, both are protected. That's why they are new information from Mao. Yani R1 have two roles. One is they also protect Mao. They also determine alpha and
beta.
Oh, doctor.
now clear?
Doctor.
You say
Yes.
this is for the exam.
See,
What about the exam? We choose both 1 and 2.
we should, because they are new information.
So
We are here, not really.
not ignore it.
No, not ignore. Because we need new information. Why you are going to buy new car? Why you not going to buy 2000 model?
Wallah good sir.
Ferrari
Even
number
2000 model
2.
car is very good.
Yes.
Why you buying a 2018 model for new car?
بتشتري سيارات ما تعرف المواصفات.
So okay.
This is the research.
Okay. So in the exam, when you put, how we know it's we know R1 for selectivity of receptor, R2 for protect.
I will mention in the question. I will mention very clear in the question.
What? How?
Like suppose that here.
Suppose, now example. If you give us a question, which are responsible for protect N-terminal.
Yeah.
R1, R2, both.
See, yeah, they are very good questions. You are asking from exam point of view. See, this R1 is the 100% alpha and beta. This R2 is 100% from MAO.
Yeah.
But in the new book, Graham Patrick, in the new editions, they written as this R1
Also.
is
Also good.
also protect only about 20%. But they are protected.
Protect, but the major protection it's R2.
R2.
Oh. So what should we
So
choose? Both mention the major.
exam.
Not both.
Only R2.
R2.
R2 only.
Only R2 in the exam.
فضل
But okay, for information, R1 it's
Yes.
R.
That's why I clear.
Okay.
Because you should know new thing.
Okay.
Now come on here. See here. See here. They have what we know here, metabolic pathway. OD-methylation, OD-methylation. Hydrolysis, yeah, hydrolysis, amide linkage. OD-methylations, OD-methylation. Now here becomes OH. Then, can this compound metabolize by COMT?
No.
No.
Can this metabolize by MAO?
No.
Their activity of the compound
Increase.
as compared to
It's
epinephrine?
lipophilic doctor.
Huh?
Some has some lipophilicity.
Yeah.
CNS effect.
Huh? Sinus effect.
I didn't understand so well.
MAO. Because here I have the R2. R2 have CH3 and C2H5. They protect this amino group from the MAO chain.
So MAO act when there is no protection.
MAO will not act here.
Yeah, but act and there is no protection.
No, if they have no protection, then they act.
Yeah.
Yes.
They make protection.
Yeah. Now see here, imidazoline.
Doctor, make it next week because the time is
Time what time? 50. Leave. Now we start from here. Imidazolines
No problem.
from the next classes.